In this lecture, we will derive the following thing. If you have a region filled with an electric field, what? You have a particular vacuum, so this is considered vacuum, and this vacuum is filled with an electric field E. Is filled with an electric field E. Then it is said that per unit volume, so if I take a unit volume of the vacuum in which the electric field is lying, then per unit volume of the vacuum, the energy stored is half epsilon naught E square. So this is the energy stored per unit volume in an electric field. Now the question is, how can an electric field in a particular region store energy? Because we know that energy comes from work done. So who has done work to create this energy? Actually, the work is done by us, because to create this electric field we always do work. To create an electric field in a particular region, always work is done, and that work done is stored as the electric field energy. So let us try to derive this part, and we'll try to understand this. So remember Gauss law. We'll use a bit of Gauss law. So consider you have an infinite sheet, and this infinite sheet contains plus charge, positive charge, and the charge per unit area is represented by sigma. Remember, sigma was my charge per unit area. So when we calculated the electric field due to this infinitely charged sheet at a particular point P, then using Gauss law we find that the electric field is equals to sigma by 2 epsilon naught. So this was quite interesting, because it says that for an infinite sheet the electric field is same and it is independent of where you are calculating. For example, you can calculate an electric field at this point and it will say that the electric field is same, because as you go farther away from this sheet, more and more charge on the other side of the sheet will contribute to the electric field. As a result, the decrease in electric field as you go far away is compensated by the increase in electric field due to the show up of extra electric field from the upper charges. Now, this is a system of infinite sheet, but we can use this formula even for a finite sheet of charge. For example, consider a finite sheet of charge with charge q. Then the electric field due to this sheet of charge will be E is equals to sigma by 2 epsilon naught. Now this formula is valid only when you are very near to the point. For example, if you are calculating electric field very near to this finite sheet, only then this formula is correct. Because when you are very much near to this finite sheet, for this point which is very near to the sheet, this sheet will behave as if it is very large. Agreed? Now this can be in turn written as the charge carried by the sheet divided by 2 epsilon naught. A is the area of the sheet. Agreed? Now what I'll do is I'll do something interesting. You know that electric field produced by this sheet is sigma by 2 epsilon naught, that is sigma that is charge divided by 2 epsilon naught A. What if I place another sheet very much near to this sheet carrying a negative charge q. I mean, this sheet which is kept very much near to the first sheet carries a negative charge. Now, what will happen? Obviously, the first sheet with positive charge will try to attract it towards itself. It will try to attract the negatively charged sheet towards itself. Can you calculate the force? Yes, we can easily calculate the force. So force with which it will attract is, so electric field that the first sheet produces into the charge of the second sheet. What is the charge of the second sheet? The charge of the second sheet is minus q. The overall minus sign in the force represents that there is an attractive force. So what is the value of this force? The value of this force is minus q square divided by 2 epsilon naught a. Okay. So for a moment, forget the minus sign and just keep the mod. So the force with which the first sheet attracts the second sheet is, can be given by mod of f. Okay, I'm least concerned with the minus sign, is equals to q square divided by 2 epsilon naught a. Agreed? Now, this can also be written in a very tricky manner. We'll do it later on. So consider this is the force. So why I'm doing this? Now consider an experiment. Consider I have a sheet here and this sheet is completely positively charged. So if this sheet is completely positively charged, I can say that this sheet carries a charge of plus q. Now consider another sheet very near. The distance between these two sheets are so small that is, it is approximately 0, and the second sheet carries negative sign. I mean, it carries a negative charge minus q. Now imagine when I started with these two sheets, the distance between them is approximately 0. Agreed? And the force with which the plus q sheet is attracting the minus q sheet is given by q square by 2 epsilon naught a. Now what I'll do is I'll push the minus q sheet away from the plus q sheet. Now to do this, I need to work against the attractive force of plus q on minus q. So finally, after so much of hard work, if I succeeded in creating a distance between the two sheets. So the first sheet with a negative charge with a positive charge plus q, and the second sheet, after so much of hard work, I was able to pull the second sheet away from the first sheet through a distance of x. So what is my work done? So my work done equals to F into x. So this is my work done. So I can write this as half q square divided by epsilon naught a into x. Now can you tell me, I have done a lot of work in separating these two sheet of charge. Where does my work go? Well, when I separated it, indirectly I created an electric field in this region of space, and this electric field E that is created by me was due to my work done, and we'll see that this work done will automatically give me my energy density. So let us do some more calculation. Now can you tell me what is the value of this electric field that is created between these two sheets? Well, the value of electric field created between these two sheets, let me put it as x dax. Okay, so that you understand, or let me not put x. So the value of this electric field is sigma by 2 epsilon naught, that is the electric field created by plus q, and also there is an electric field created by the other charge. So just using the mod, I'm just forgetting the charge. Okay, I can write that the total electric field that is inside, that is in between the two sheet, is sigma by epsilon naught. Remember that this electric field is not equal to this electric field, both are different. One electric field is the electric field due to only one sheet. This electric field is the electric field between the two sheets due to both the sheets. Now what happens to my equation here? Now my work done will become, now convert everything in terms of sigmas, so it will become half. So I can write this as sigma into q divided by 2 epsilon naught. So I can write this as this into x. So remember that here my sigma by epsilon naught is the electric field. So what can I do now? So I can write my work done as half into, so I have actually I wrote this half twice, so let me rub it. Okay, so half into q into E is the electric field between the two systems into x. Now going further, what just do one thing, write q in terms of sigma and a and multiply epsilon naught up and down. So what I'll do is, so what is q? You know that q is sigma into a. So electric field keep as it is. Now multiply an epsilon naught up and down. Just multiply an epsilon up and multiply an epsilon down. Doesn't matter, it's the same thing. Now look at another interesting thing. Again you can make this sigma by epsilon naught as an electric field. So what do you get in the third step? You get half, you get an epsilon, you get an e square multiplied with a into x. Can you tell me what is a into x? A is the area of the sheet and x is the distance. So a into x is the volume inside the two sheets. So what is the total work done in create? So total work done is half epsilon naught e square into volume. So the entire work done, so the work that I have done in separating the two sheets by a distance x. Okay, so I have done a lot of work in separating the two sheets by distance x, and that work done is this. And that work done has gone into creating this particular energy in the entire volume V. Now, can you tell me what is the energy per unit volume? So the energy per unit volume can be written as half epsilon naught E square. So this is the energy stored in an electric field, which I have just proved. Agreed? So this is energy stored in an electric field per unit volume. So remember this, energy stored in an electric field per unit volume. That's why it is called energy density. It is called electric energy density. Agreed? Now similarly, we can calculate, consider if you have a magnetic field, then you can easily calculate what is the energy stored in a magnetic field in vacuum. Now please understand, this formula is for vacuum because the epsilon naught that we have used here is for the vacuum. So in the next lecture we'll find energy stored in a magnetic field.